Welcome back, ladies and gentlemen. In the previous video, we discussed about understanding spatial data science, where we started on the definition of spatial data science and later discussed the unique aspect of spatial data science. We also answered the question, why is spatial data science so important? One of the answers was spatial data science is not simply geographic information system, neither is it a database management system, nor is data analytics or big data problem. It is rather the combination of all the disciplines. Kindly watch the previous video on understanding spatial data, part 1 to 4. The link is on the video description section. If you have not subscribed to my channel, kindly subscribe to my channel and then click on the notification bell to be notified whenever I upload a new video. Now let's move to today's topic. In this video, we would like to discuss about solution structures of spatial data science problems under the topic Spatial Data Science and Applications. The outline of today's lecture will include 4 disciplines for spatial data science and applications: open source software, spatial data science problems, spatial data versus spatial big data. Now let's move to 4 disciplines to have some expertise on in order to claim a role of spatial data scientists. They are, as you can see, Geographic Information System, that is the GIS, Spatial Database Management System, Spatial Data Analytics, Big Data System. Definitely, application domain knowledge will be a big plus, such as business, urban planning, transportation science, public health, disaster management, and any domain where spatial data are intensively used. Now, let's briefly review each discipline one by one. GIS stands for Geographic Information System. It can be defined as a system which collects, stores, and manages, queries, analyzes, visualizes spatial data. In a wider definition, a system which combines hardware, software, data, people, or organization and policy regarding spatial data. GIS can be considered as the limited version of CAD for spatial data production, database management system for data management, and data analysis tool. The most powerful aspect with GIS is that it is a geovisualization tool which is specifically designed for cartographic representations of spatial data. In other words, map making is well supported. There are quite few GIS softwares in commercial market as well as in open source software domain. These commercial or proprietary GIS softwares are ArcGIS. ArcGIS undisputedly the leading GIS software. Hexagon Geospatial, Map Info Professional, Global Mapper, Small World, and Bentley Map, as well as a Pitney Bow Map Info. On the other hand, there are also open source software in the industry such as Quantum GIS, Diver GIS, Geoda, GVSig, Map Window GIS, SAGAS, that is System for Automated Geoscientific Analysis, Environmental Benefits Mapping and Analysis Program, BEMAP. Among the open source software above, QGIS and DBMS are the most popular. Pros of using GIS is that it has a basic capability of handling GIS analysis and management of data. It can also cover to a certain degree most all the processes of spatial data science and applications. Spatial data production, spatial data management, basic query, geoprocessing, some advanced analysis, and geovisualization. It can do everything. On the other hand, GIS has limitation that it can handle almost all aspects of spatial data science only with limited capability. It has deep database management system functionality, but it does not support standard query language and general design only for single user, meaning that GIS does not support some concurrency control, some analytical power, but it's not fully fledged. Furthermore, generally no big data functionality is presented. Spatial Database Management System. What is spatial database? A database that stores spatial objects and also provides operations to manipulate spatial objects. What is spatial database management? Spatial database management system is a database which can store and query not only conventional data set of number and text, but also user-defined data types of spatial data, such as point and polygon of vector objects and images of raster objects. It became feasible after object relational database management was developed. Spatial database management softwares are basically object relational database management system with the spatial data of built-in data types and spatial query language. Examples include Oracle Spatial, an extension of market-leading database management system Oracle, PostgIS, which is an extension of PostgreSQL, and open source software Microsoft SQL. Some limited versions of spatial database management are Spatialite and ArcGIS. Spatial database management inherited all the database management system functionality. So removal of redundant and inconsistent data, concurrency control, backup, and recovery are supported. In other words, characteristics of ACID, which stands for atomicity, consistency, isolation, and durability, are given and supported. In addition to that, as the name goes, it has spatial data type and spatial operations and spatial query language. Spatial data indexing and spatial query optimization are supported as well. However, it also has some limitations. Spatial database management has only limited operations supported in query language, so that it cannot deal with high-end modeling and analytics of spatial data. A visualization is also a big limitation. At the same time, just like any other database management system, spatial database management has weaknesses of big data management, which is based on different paradigm. Now, data analytics. It can be defined as data analytics is the science of analyzing raw data to make conclusions about that information. The techniques and processes of data analytics have been automated into mechanical processes and algorithms that work over raw data for human consumption. Data analytics help a business optimize its performance. Generally, it takes a series of processes such as cleansing, selecting, transforming, modeling, and summarizing data. There are many data analytic tools for domain-specific or generic purpose. There are a variety of data analysis tools of commercial or open source. R is the most renowned data analytic tool in open source community, which has its own ecosystem in which any developer can build his or her own package for spatial data analytics. R is a programming language for statistical computing and graphics supported by the R core team and the R Foundation for Statistical Computing, created by statisticians Rose Harker and Robert Gentleman. R is used among data miners and statisticians for data analysis and developing statistical software. 9. First released in 2006, NIME's analytics platform has quickly been adopted by open source community companies and software vendors who use it to create data science. The open and intuitive software makes understanding data easy. You can create visual workflows using the drag and drop graphical user interface. Model your analytical steps while controlling data flow and ensure your work is current. Rapid Mana are also popular open source solutions. Rapid Mana is a cloud-based suite of products that helps you create an integrated end-to-end analytics platform. The open source product offers a wide range of features, including automation, through which it loops and repeats tasks and can complete in database processing automatically. The software also offers real-time scoring, which lets you work with the third-party software to apply statistical models. It operationalizes pre-processing, cluster, predictive, and transformation models. Grafana is an open source data analytics platform that allows you to monitor and observe metrics across different apps and databases. You get alerts that notify you when specific events happen, along with real-time insight into external systems. The above are some of the most popular open source software for data analytics. In commercial arena, there are many of data analytics tools such as SAS, that is a business analytics. The high-grade text analytics capability of SAS-based business analytics software allow users to inspect and transform and organize text data into relevant information that analysts can't explore to discover meaningful insight. Statistical Package for the Social Sciences (SPSS) is a very powerful and popular business data analytic tool. The SPSS software platform offers advanced statistical analysis, a vast library of machine learning algorithms, text analysis, open source extensibility, integration with big data, and seamless deployment into applications. Tableau Big Data Analytics. Experts agree that Tableau Big Data Analytics is one of the best business analyst software, given its dynamic and cutting-edge capability for unstructured text analysis. Tableau Business Analytics platform, which includes robust and reliable statistical tools, empowers users to perform an in-depth analysis of social media networks and predict patterns based on current and historical data. If you want more freedom in data analytics, then you can also consider direct programming language with many data analysis libraries such as Python and Java, or computing environments such as MATLAB as well. Now let's move to pros of data analysis or pros of data analytics. Data analytic tools are generally easy to use, provide a platform to build your own analysis, integration potentials. Quite few open source solutions has big advantage with intuitive graphic user interface and simple script language. There are quite a few excellent tools in open source community. The cons of data analytics tools are limitation in spatial data analysis, lack of spatial data management, limited geo-visualization capabilities, domain-specific, and too many solutions. Now let's move to big data systems. What is big data? Big data refers to the large, diverse sets of information that grow at ever-increasing rates. It encompasses the volume of information, the velocity or speed at which it is created and collected, and the variety or scope of the data points being covered. Big data often comes from data mining and arrives in multiple formats. In the past, high-performance computing generally meant distributed system of task parallelism, meaning that competition jobs are distributed to each node. In the era of big data, data distribution as well as computation job distributions are required. The concept and programming model is called the MapReduce. Hadoop is an open source software with file system named Hadoop Distributed File System HDFS, which is an implementation of programming model of MapReduce. Hadoop has only limited capability of supporting distributed storage and computation, and even no support for accessing or updating individual data. Hadoop ecosystem is a platform or suite which provides various services to solve the big data problems. It includes Apache projects and various commercial tools and solutions. There are four major elements of Hadoop: HDFS, MapReduce, Yen, and Hadoop Common. Most of the tools or solutions are used to supplement or support these major elements. All these tools work collectively to provide services such as absorption, analysis, storage, and maintenance of data. The following are the components that collectively form a Hadoop ecosystem. HDFS, Hadoop Distributed File System. HDFS is the primary or major component of Hadoop ecosystem and is responsible for storing large data sets of structured or unstructured data across various nodes and thereby maintaining the metadata in the form of long files. HDFS consists of two core components such as name node and data node. Yen, yet another resource navigator, as the name implies. Yen is one who helps to manage the resources across the clusters. In short, it performs scheduling and resource allocation for the Hadoop system. It consists of three major components such as resource manager, nodes manager, and application manager. MapReduce, programming-based data processing by making the use of distributed and parallel algorithms. MapReduce makes it possible to carry over the processing logic and has to write applications which transform big data sets into manageable ones. Spark, in memory data processing, is a platform that handles all the process consumptive tasks like batch processing, interactive or iterative real-time processing, graph conversion, and visualization. It consumes in-memory resources, hence that's being faster than the prior in terms of optimization. Spark is best suited for real-time data, whereas Hadoop is best suited for structured data or batch processing. Hence, both are used in most of the companies interchangeably. Pig was basically developed by Yahoo, which works on a pig Latin language, which is query-based language similar to SQL. It is a platform for structuring the data flow, processing and analyzing huge data sets. Pig does the work of executing commands, and in the background, all the activities of MapReduce are taken care of. After the processing, B stores the result in HDFS. Pig Latin language is especially designed for this framework, which runs on Pig runtime. Just the way Java runs on the JVM.pig helps Java. Just the way Java runs on the JVM, Pig helps to achieve ease of programming and optimization, and hence is a major segment of Hadoop ecosystem. Hive, query-based processing of data services. With the help of SQL methodology and interface, Hive performs reading and writing of large data sets. However, its query language is called HQL. Hive query language is highly scalable as it allows real-time processing and batch processing both. Also, all the SQL data types are supported by Hive, thus making the query processing easier. Similar to the query processing framework, Hive 2 comes with two components, JDBC drivers and Hive command line. JDBC along with ODBC drivers work on establishing the data storage permissions and connection, whereas Hive command line helps in the processing of queries. HBase, NoSQL database. It is a NoSQL database which supports all kinds of data and thus capable of handling anything of Hadoop database. It provides capabilities of Google Big Table, thus able to work on big data sets effectively. At times where we need to search or retrieve the occurrence of something small in a huge database, the request must be processed within a short, quick span of time. At such time, HBase comes handy as it gives us the tolerant way of storing limited data. Mahat, Spark MLRB. Machine learning algorithm libraries. Mahat allows machine learnability to a system or application. Machine learning, as the name suggests, helps the system to develop itself based on some pattern, user or environmental interaction, or on the basis of algorithm. Solar, Lucene, searching and indexing. These are the two services that perform the task of searching and indexing with the help of some Java libraries, and is based on Java, which allows spell check mechanism as well. However, Lucene is driven by SOA. Zookeeper, managing cluster. There was a huge issue of management of coordination and synchronization among the resources or components of Hadoop, which resulted in inconsistency. Often, Zookeeper overcame all the problems by performing synchronization in component based on communication, grouping, and maintenance. OOS, job scheduling. OOS simply performs the task of scheduler, that's scheduling jobs and binding them together as a single unit. There's two kinds of jobs, OOS workflow and OOS coordinator jobs. OOS workflow is the jobs that need to be executed in a sequentially or ordered manner, whereas OOS coordinator jobs are those that are triggered when some data or external stimulus is given to it. Likewise, additional needs brought a new solution to Hadoop ecosystem and keep growing and changing. Hadoop framework presents capability of big data management and analytics, which used to be impossible with existing technology for big data processing. It can present both scalability and resilience for data management, flexibility and speed of data analytics. Additionally, they are all open source solutions. They are all big advantage of using big data systems. There are also disadvantages of big data system. The most critical issue of the data system for us is that it's not designed for spatial data. Hadoop is a shared nothing structure, so that it's good for only independent computing with big data. Any advanced spatial analysis can hardly be implemented in Hadoop framework. Certainly, no capability of spatial and geovisualization. Hadoop shared nothing structured, good for only independent simple parallel computing with big data. So far, we have briefly reviewed the 4 different disciplines to understand in order to claim a role of spatial data scientists. There are GIS, spatial database management, data analytics, and big data system. It is obvious that each discipline has pros and cons, advantages and disadvantages, and they need each other. Throughout this course, you will learn each discipline from basic to advanced. Alright, this is the end of the lecture. If you've not subscribed to my channel, kindly subscribe to my channel, like, share, and comment. Hello everyone, welcome to today's lecture. Before I proceed to today's lecture, I would like to recap what we have learned in our previous lecture. In the previous lecture, we discussed the 4 disciplines for spatial data science and applications, which is GIS, spatial database management, spatial data analytics, and big data system. If you've not watched the previous video, kindly look at the description part of this video to have access to a link to watch it. If you've not also subscribed to my channel, kindly subscribe to my channel for more updates. In this lecture, we are going to learn about open source software for each of the disciplines discussed in the previous video. Let me specifically give you an outline of the lecture. The outline of this lecture will entail what is open source software. This will involve a brief introduction to open source software, and then introduce QGIS for GIS, PostGIS for Spatial Database Management System, R for Spatial Data Analytics, Hadoop for Big Data System. What is open source software? Open source software is a computer software that is released under license, in which the copyright holder grants users the right to use, study, change, and distribute the software and its source code to anyone and for any purpose. Open source software shares similarities with free software, and it is part of the broader theme free and open source software. It should be noted that open source software is open to use, but sometimes it is not always free. For example, if you develop a commercial solution based on open source software, you may have to pay for legal protection. The negative aspect is no maintenance and no support. QGIS, also known as Quantum GIS, is the leading open source GIS software. QGIS is free and open source cross-platform desktop Geographic Information System application that supports viewing, editing, printing, and analysis of spatial data. QGIS functions as Geographic Information System software, allowing users to analyze and edit spatial information. In addition to composing and exporting graphical maps, QGIS supports raster, vector, and mesh layers. Vector data is stored as either point, line, or polygon features. Multiple formats of raster images are supported, and software can georeference images. Pros of Quantum GIS. It is free to use. Quantum GIS is one of the applications of its sort that is completely free to use. However, it comes with some features and core plugins that will provide basic usability. User-friendly graphical user interface. Although you can find many applications with the same capabilities out there, Quantum GIS is the best of all because it has a very simple and user-friendly graphical user interface. This means that you can access basic tools such as the spatial bookmarks, map composer, annotations tools directly on the interface. It offers incredible digitizing platform besides its abilities to help you review, edit, and analyze geospatial data. QGIS also offers incredible digitizing solutions for GRASS vector layers and also the OGR supported formats. Its ability to extend functionality. The app has one major benefit, which is its ability to extend its functionality through the use of plugins. It is more versatile than ArcGIS. The fact that this platform is Mac and Linux friendly makes it one of the best out there for the versatility. Quantum GIS also has many cons and disadvantages, which can be disheartening, especially when someone is considering an alternative. Here are some of the cons. Limited functionality for advanced analysis, not perfect for those who mainly want to create maps. As much as this application is the best in the market in terms of data viewing, editing, and analysis, many people wouldn't recommend it to people who mainly want to create maps. The map making features are very cumbersome. This is why many people, especially those that want to create map, don't choose Quantum GIS. PostgreSQL is free and open source relational database management system, emphasizing extensibility and SQL compliance. PostGIS Spatial Database Extender for PostgreSQL Object Relational Database. It has support for geographic objects, allowing location queries to be run in SQL. PostGIS runs on top of PostgreSQL. PostGIS added spatial data types, spatial functions for query and data management, spatial indexing, and so on. The origin of PostgreSQL and PostGIS goes back to Ingres, the first relational database manager from UC Berkeley. With a long history of development, PostGIS is a very solid and reliable open source software. The figure shows Postgres interfaces from the upper left corner to clockwise command the window, administrator window, and database table view. Now, data analytics tool. R is a programming language for statistical computing and graphics supported by RC, the R core team, and the R Foundation for Statistical Computing. Created by statisticians Ross Harker and Robert Gentleman, R is an open source software. R is used among data miners and statisticians for data analysis and development statistical software. Users have created packages to augment the functions of R language. For spatial analysis, there are more than 100 packages available, and SP is one of the leading packages and the most popular package. Now, big data system. As discussed in the previous lecture, Hadoop ecosystem is designed for big data management and processing based on MapReduce programming model. Our problem is that Hadoop is not designed for spatial data of which values are spatially correlated, which should be considered in a data processing. And spatial data structures are tightly woven to each other to present topology. There are a few alternatives of big data system for spatial data, such as Spatial Hadoop from the University of Minnesota and GIS Hadoop from Emory University. With respect to such efforts, based on my experience, Hadoop framework will work only for independent and basic operations such as noise removal and data pre-processing. But management of spatial big data in Hadoop framework will have many issues. There are two major challenges for managing and querying massive spatial data to support spatial queries: the explosion of spatial data and the high computational complexity of spatial queries. As mentioned before, Hadoop ecosystem provides additional tools to facilitate the processing and management of big data such as Hive, HBase, and Yen, and many others. Additionally, Python and Java can directly access ADFS and process big data, or even spatial big data. R can also integrate with Hadoop framework for direct analysis of big data in spatial big data. In this video, we'll learn about open source software. I gave a brief introduction to QGIS, PostgIS, R, and Hadoop. Throughout my course, I will give you hands-on experiences with each software, and you will make use of them for your assignments and projects. If you like my videos, kindly subscribe to my channel and click on the notification bell to be notified whenever I upload new video. Welcome, ladies and gentlemen, to today's presentation. Before I proceed to today's presentation, let us recap what we have learned in the previous lectures. In the previous lectures, we discussed about the four disciplines of spatial data science. That is the Geographic Information System, Spatial Database Management System, Spatial Data Analytics, and Big Data System. These four disciplines are very important to master to be able to be called a spatial data scientist. And I presented appropriate open source software for each discipline. If you've not watched the video, kindly look at the description part of this video to have access to link to watch it. And also, kindly subscribe to my channel if you've not subscribed yet. In this lecture, we will discuss about spatial data science problems. I will categorize spatial data science problems into 6 groups in terms of solution frameworks. As shown in the slide, 6 problem types are desktop GIS, server GIS, spatial web, spatial data analytics, spatial data management and analytics, spatial big data management and analytics. For each problem type, I will explain how the solution framework can be used. Spatial data science problems could be simply defined as problems associated with where for either the input data or output results, or both. Examples are: where is the best place for a new restaurant in Accra, Ghana? What is the emotional condition based on his or her trajectory now? We do not have a clear answer to the questions yet, but it will be very meaningful question in mobile IT companies or business. If you have reliable solution, Microsoft or other major IT companies will buy and use it for their personal assistant. For example, Kathuma for Windows 10. The first category of spatial data science problem is named as desktop GIS or single user GIS. As mentioned before, GIS can deal with almost all aspects of spatial data science so that it can handle spatial data science problem by itself. Spatial data science problems with desktop GIS will be characterized by the following. First of all, data size is relatively small and only single user is assumed. In other words, a standalone application. In terms of level of analysis, desktop GIS can deal with basic spatial analysis only. The main focus will be placed on mapping and geovisualization. The second category is named as Saver GIS or Multiple User GIS. It uses GIS and Spatial Database Management System. The major difference from the desktop GIS will be data size and data management issues for multiple users. So that Saver GIS can be characterized by the following. Data size is generally bigger than desktop GIS, for example, of 100 megabytes. In order to support multiple users, full functionality of database management system should be supported, such as transaction management with atomicity, concurrency, isolation, and durability, SQL and data indexing and query optimizations, and so on. Main focus will be placed on data management with database management system and mapping geovisualization with GIS. The best example will be a Saver GIS for the local government. For example, country governments in Ghana, they generally have quite few spatial data in-house for their operation every day. Cadastral data of parcel boundary and ownership, certified surveying maps, zoning data for land use planning, tax roll for taxation, utility layers such as water supply and sewage, parking and transportation, and many others. The datasets should be well managed in database, and individual departments should be connected to those spatial database management systems and conduct their works and operation with GIS. The focus will be data management with database management system and mapping and basic operation with GIS. The next type is spatial web or web GIS, which is also known as web mapping, which is a process and application of making spatial data dissemination. Simply put, web GIS is a pattern or architectural approach for implementing a modern GIS. It's powered by web services, the standard services that deliver data and capabilities and connect components. Web GIS can be implemented in the cloud using ArcGIS Online, on premises using ArcGIS Saver, or more typically as a hybrid combination, leveraging the best of both worlds. Web GIS isn't new. In fact, it's been evolving for a long while, but we have actually passed a tipping point where innovation in GIS and related technologies have made web GIS not only possible but essential. Web GIS brings GIS into the hands of the people. It reduces the need to create custom applications. It provides a platform for integrating GIS with other business systems and enable cross-organizational collaboration. Web GIS allows organizations to properly manage all their geographic data. Geographic Information System has the potential to go beyond mapping GIS after diverse set of analytical functions. The emergence of web GIS unlocking the power of GIS to a wider audience, helping in decision-making process. Web GIS rely on Java, Netflix, and run on multiple platforms. 2. Supports a large number of users simultaneously. Web GIS relying on HTML client supports different operating systems, better cross-platform capability. However, Web GIS for mobile clients is far from being cross-platform because of the diversity in mobile OS and incompatibility of mobile web browsers. Easy to use for end users, compatible with different web browsers, Google Chrome, Internet Explorer, Firefox for diverse OS, Win, Linux, Mac OS, and iOS. Undefined system update offers chunky demographic datasets and imagery map layers, which allow users to access immediate context from different applications. Customization dashboard with a user-friendly interface. The web GIS has diverse range of applications. Some of uses are listed below. mapping, stroke visualization, and query attribute or spatial collaborative collection or geospatial information, geospatial analysis, measurement, optimal driving path, routing, pollution, dispersion modeling, retail site selection. WebGIS as a new business model and a new type of commodity, location-specific advertising and branding based on mapping. GIS application is an engaging and powerful tool for designing and planning government projects like flood management, forest management, mapping, and natural disaster. WebGIS technology is used in geoscience research collaboration. WebGIS Daily Life, a location-based service supported by mobile web, smartphones, and tablets. LBS involving service to identify a location of person or objects, such as discovering the nearest ATM, restaurants, shops, and hotels. Also include parcel tracking and vehicle tracking services. The next type is spatial data analytics. GIS can deal with geoprocessing and basic spatial analysis, but it has limited analytics power. For example, very limited functionality for statistical analysis. In case you need to conduct advanced spatial analysis, it is required to connect the GIS with data analysis tool. In our framework, QGIS for GIS with R for data analytics. Spatial data analytics problem can be characterized by the following. It has relatively small data sets for single user so that GIS can deal with it. Main focus must be placed on flexible and advanced spatial data analysis. Mapping and visualization is also important. A simple example is statistical analysis with spatial data. The next type is spatial data management analytics. This type can be characterized by the following. The data size is generally large and it has multiple users. For that, full functionality of database management should be supported. Main focus should be placed on both spatial data management with database management system and advanced spatial data analytics with data analytics tool. The next type is entitled as Spatial Big Data Management and Analytics. Big data systems such as Hadoop-based, H-based, and prime language like Java and Python deal with pre-processing and refine the big data in order to make the data stored in spatial database management system or conduct direct analysis with Hadoop ecosystem. Spatial data science problem in the type can be characterized by, first of all, big data science at a minimum of 100 gigabytes, and then data management with database management system and flexible and advanced analysis. And mapping and geovisualization are all important. All right, this is the end of this lecture. Thank you for your attention and see you in the next lecture. Before you go to the next lecture, kindly subscribe to my YouTube channel to help push me. Thank you. Ladies and gentlemen, welcome to today's lectures. Before I proceed to today's lectures, let us recap what we have learned in the previous lectures. In the previous lectures, we've discussed 4 disciplines related to spatial data science. That is GIS, Spatial Database Management System, Big Data System, and Data Analytics, and open source software for each discipline. So we discussed about the open source software for each discipline, where we talk about what is open source software and other related issues. If you've not watched this video, kindly look at the description part of this video to have access to a link to watch it. And also kindly subscribe to my YouTube channel to support me to grow. So today's lecture, let me give you an outline of this presentation. The outline of this presentation will include introduction of spatial big data, its definition and the examples, In the end, I will give you a brief overview of the value of spatial big data. In other words, what we can do better with spatial big data than with only spatial data. Let me kindly give you a little background on spatial data. It is important to know that more than 80% of all information in society has spatial reference. Spatial data is data with a direct or an indirect geographic reference to the surface of the earth. Spatial data is an indispensable part of basic infrastructure of every country, as are roads, hospitals, and schools. Spatial data is strategically important to decision makers at all levels. Spatial data is information that describes objects, events, or other features with a location on or near the surface of the earth. Geospatial data typically combines location information, usually coordinates on the earth, and attribute information, the characteristics of the object, events, or phenomena concerned, with temporal information, the time or lifespan at which the location and attributes exist. The location provided may be static in short term. For example, the location of a piece of equipment, an earthquake event, children living in poverty, or dynamic, for example, moving vehicle or pedestrian, the spread of an infectious disease. They generally accompany attribute data, which describe name, condition, and other information. Spatial data is also known as geospatial data, or geodata, or GIS data. Geospatial data typically involves large sets of spatial data gleaned from many diverse sources in varying formats and can include information such as census data, satellite imagery, weather data, cell phone data, drone images, and social media data. There are uncountable spatial data examples as mentioned above. Let me also give you more examples such as parcel boundary, road network, river network, land use, land cover data, digital elevation model, which depicts the surface of the earth, orthophotos, which are photos as well as maps, some 3D maps, which are recently available in many applications. Geospatial data is most useful when it can be discovered, shared, analyzed, and used in combination with traditional business data. Spatial data is represented by two data models. These are vector data model and spatial data model. Now let us discuss about spatial big data. Spatial big data can be defined as spatial data with big data characteristics, or opposite way around, big data with spatial context. Spatial big data exceeds the capacity of commonly used spatial computing system due to volume, variety, and velocity. Spatial big data comes from many different sources, such as satellites. These are quite a few satellite imaging systems which generate a homogeneous size of spatial data every day. For example, Landsat 7 system can theoretically downlink 17 terabytes of satellite image data per hour. Drones, vehicles, that's vehicle trajectory, which is well known spatial big data. For example, taxi trajectory in Accra City, card transaction data with locations such as credit card and public transit card. Geosocial networking services, mobile devices, cameras, a collection of sensor data with location also produce spatial big data. Some types of spatial big data are speed every minute for every road segment. GPS trace data from cell phones, engine measurements of fuel consumption can be estimated from fuel levels, distance traveled, and engine idling from engine RPM and greenhouse gas emissions. Some of the challenges of spatial big data are listed as retaining computational efficiency, storing spatial big data into cloud and applying new data when spatial big data or change old data. Now you are looking at a list of application flows. They are eco-routing for minimization of fuel consumption, urban traffic analysis for optimization of transportation service, real-time city operation for disaster response and mitigation, geosegmentation for marketing with floating population data. Other examples are spatial business intelligence and geopolitical analysis with geo-tagged SNS data. They are good examples for natural science, climate change study with satellite image analysis will be a good example of spatial big data. Another example I have is the healthcare application. In this lecture, you studied on spatial data and spatial big data as input material for spatial data science. I believe spatial data science gains more and more importance and significance in many application fields after we have spatial big data available, which can present better insight as well as more accurate analysis. This is the end of the video in which we have discussed related discipline to spatial data science, software, solution framework, and datasets. Hopefully, you have enjoyed it. In the next video, we will discuss each discipline of spatial data science in more detail. See you then. Before you go, kindly subscribe to my YouTube channel to support me to grow. Thank you.